Hello, everyone. My name is Alena Prokharchyk. Originally, I'm from Eastern Europe. Now I live in California. And this is my second time to Australia. And I'm considering moving here. It is a great country, great culture, people, work-life balance. I love everything about it. And I'm an engineering manager at Rancher Labs, where we build solely open source software. And I've been building an open source software since 2009. I'm very invested in the open source community. I'm also on the CNCF board, and we're helping to bring all the innovations into space and make them work together. And in Rancher, the majority of our projects are around Kubernetes, extending Kubernetes, managing Kubernetes clusters. We also have a recent project, minimalistic Kubernetes distribution for the edge computing use cases. And I'm curious to know how many of you are using Kubernetes today in your infrastructure. Awesome. And how many are thinking about moving to using Kubernetes? That's great. And the majority of the presentations that I've given in the past were around extending Kubernetes from the developer perspective. How do you write plugins for Kubernetes? And the interesting thing happened is, after all my presentation, I was approached by people who are asking, how do you actually structure your Kubernetes cluster? How do you decide on how big your Kubernetes cluster should be? Should you go for one big cluster or many smaller ones? And today, I'll try to cover all these topics with some examples that I've seen on our users, open source users, and customer setups. But let's start from the very beginning. Making the right choice is not always easy when it comes to delivering your workloads. And the transition from the virtual machine to the containers can take time. The containers existed well before Docker, but Docker made them really usable by the end user, really easy to use and adopt. But as you understand that similar to the virtual machines, somebody has to orchestrate your application, containerized applications. And I've been working with Kubernetes from the very beginning, and its popularity did not come right away. There was Docker Swarm, Mesos, and Kubernetes came a little bit later, but it got such a rapid adoption. And the reasons why it happened, because, of course, it came from Google. Google has a great reputation. And Kubernetes has been used heavily for the internal workloads. And from the developer point of view, I think this is the greatest platform because it's easy to extend its functionality without actually contributing to the core code base. You can develop the plugins on any level. It can be a container runtime. It can be the cloud provider. It can be the webhooks. And the Kubernetes community is great. It has a lot of people involved that manage the releases, that review the PRs, and everybody is very friendly. They run online meetups just to help the Kubernetes adoption. But the Kubernetes is great and extendable, but is it really easy to use? And when it comes to coming up, making your containerized workload deployed in Kubernetes, it is not very easy to switch the concept when you switch from the Docker Compose into the Kubernetes. It's not easy. And if you try to explain it to the users, I actually tried to explain it to my mom, and it was very hard. Unfortunately, she does not speak English, and I couldn't show her this video. But this video is awesome. It is explained so well on how do you create your application workload in the Kubernetes, how do you deploy it, how do you expose it to the outside. This is very cool. But when you think about your Kubernetes cluster orchestration, there is a whole new level, as Kubernetes cluster itself consists of so many components: etcd database, API server, kubelet, and all the add-ons that you can plug in to enable DNS, load balancing, and other components like the service mesh. And how do these all components fit together? And how do you install them either on-prem or in the cloud? And there are many tools that came during the last years that help you to install Kubernetes easy, like Hops on AWS. There is a kubeadm. So orchestrating the cluster is very easy. So like with just one command, you can roll out your cluster on any set of nodes and anywhere, either in the cloud or on-prem. But how do you actually decide on how big your Kubernetes cluster should be? There are some questions that you have to ask yourself first. First of all, you have to think of like, what is your infrastructure? Is your infrastructure solely in the cloud? And if it is in the cloud, is it just in one cloud, or you're evaluating several clouds before deciding on it? And, or is this a combination of on-prem installation and in-cloud installation? Based on what I've seen in our user setup, it's very rare to see the hybrid cloud, Kubernetes cloud, deployed in multiple cloud providers. But the combination of on-prem installation and in-cloud installation is pretty common. And the second question would be, do you need a one big cluster with like tons of nodes, Kubernetes nodes, or do you want to go with a bunch of smaller Kubernetes clusters and maybe dedicate a cluster per location or per team? And based on the model that you choose, there are going to be different set of challenges. And we're going to go over all of them in this presentation. And today, we are going to build Kubernetes clusters for semi-fictional companies. I call it semi-fictional because they actually exist. And I just cannot name it, put a specific name for it, but one of the examples would be a big corporate company which wants to have like a one big cluster, and so all the users can use it. And it's possible that there can be multiple clusters deployed on per geolocation basis. And the second example is actually my favorite one, a franchise chain. One of our early adopters was a fast food chain in the United States that actually had one cluster on per location. And it can be either on per device, or like per host, or per smaller device, like Raspberry Pi. And here are more questions to answer before proceeding with the Kubernetes cluster installation. First of all, like, where do you want to deploy your Kubernetes? Do you want to deploy them on bare metal, or you want to deploy them on the virtual machines? And if you choose the virtual machines, there is a choice whether you deploy the virtual machines on-prem or in the cloud. And if you want to roll out your Kubernetes cluster in the cloud, do you want to use the hosted Kubernetes service if it is available in the cloud? Or you just want to host your virtual machines in the cloud and provision Kubernetes cluster yourself? And then there's this ongoing question, how many clusters do you need? One or many? All right, so let's go over all of them, the bare metal or the virtual machine. Surprisingly, a lot of our users use bare metal hosts. And although virtual machines are much easier to provision and maintain, the bare metal host gives you better performance, and it also gives you more ways to customize your setup. And when it comes to the edge computing use case, of course, usually bare metal is the way to go. And when you decide of whether you provision your VM in the premise or in the cloud, you also think about like whether you need to disable access to your setup. Is it going to be the air-gap setup, or you want to make it accessible? If it's an air-gap, you might want to think about deploying it on-prem. The pros of deploying things in the cloud is providers like AWS gives you a great way of auto-scaling your application-based, auto-scaling your infrastructure based on the parameters like CPU and memory. When you can configure so when your host runs low on CPU, AWS will spin another one. And the tougher question is whether you want to go with a hosted Kubernetes in the cloud, or whether you want to provision your own. If you go with a hosted Kubernetes, the provider is going to take care of taking the HA situation, restoring your cluster, but you have less control over Kubernetes parameters. If you want to deploy your Kubernetes cluster with non-default parameters, I would suggest that you explore the tools that let you customize your Kubernetes cluster. And now, the big cluster or the many smaller ones. So for the big corporate company, one cluster might work if your company is not geo-distributed. And if you ask why can't I just create one huge, gigantic Kubernetes cluster and just roll it over all the nodes? The answer is Kubernetes does not behave really well when its components are placed too far from one another. It is true for etcd in particular because it does a sort of a heartbeat, and it can go wild if the components are placed too far. And if your components are too far from the API servers, there can be problems too. So you can deploy your one Kubernetes cluster per data center, but if you go across regions, the one cluster per region would make sense. If you're using your Kubernetes cluster to host some application that user needs to access, you can preface it with a global load balancer that, based on the geolocation of the user making a call, can forward the request to the appropriate Kubernetes cluster. All right, so when it comes to the franchise chain, the answer is obvious because you want to create a one cluster on per location on per device. It can be, you can think of like whether you need HA for the cluster, or is it going to be just one single API server, or the host where all Kubernetes components are going to be launched on one device. And in any of the case, like when you have more than one Kubernetes cluster, you might want to think about the platform that would help you to manage these Kubernetes clusters. There are many on the market: OpenShift, Pivotal, Rancher. I'm going to talk about Rancher because I've been working there from the very beginning, and I know the internals of the project. But the goal of the system like Rancher is to provide the easier management when you have multiple Kubernetes clusters, to provide the easier authentication point, and monitoring for your clusters. Okay, so Rancher 2.0. That's very interesting. So I'm currently a manager, but I'm a manager just for 1 year, and I used to be a developer, and I miss it a lot. And I've built Rancher 2.0, and what is interesting about it, the Rancher 2.0 not only manages Kubernetes, it is built on top of Kubernetes. It uses etcd as a database. All its components are Kubernetes CRDs, and all the functional components are controllers. If you're interested about writing the custom components for Kubernetes, I would really like to talk to you, as that's an area of my interest still. It is 100% written in Go. That was kind of driven by the fact that we are integrating with Docker and Kubernetes, and these platforms are written in Go. And if you look at the CNCF projects like Istio, this is also written in Go, and it's also built similar to Rancher as a Kubernetes native application that uses etcd as a database, CRDs for the object stores, and controllers as the functional pieces. Yep, Rancher API extends Kubernetes API. Yep. And here's a little bit about the architecture. So we have a management controllers that manage the user clusters, and each user cluster has its own set of controllers that run on the user cluster side. And there's a bunch of pieces that manage a certain functionality, like secrets propagation, the monitoring, the authentication, the catalog. Okay, let's get back to our big corporate company use case. What do we need to address in the setup like this? So if you think about it, it's like there are going to be many users and many departments sharing the same cluster, sharing the same hosts. So what it means is you have to take care of multi-tenancy, because when multiple users use the same host resource, you might want to think about isolating one project from another, isolating one department from another. It should be done on the resource level as well as on the networking level. Like, you don't want the traffic, you might not want a traffic to flow from one project to another. And as multiple users are sharing the same host, you want to prevent the situation when one evil tenant uses all the host resources like CPU and memory. And Kubernetes provides a really nice way to configure it. So you can do it using the resource quota, where you can just dedicate a certain amount of resources to your application, and Kubernetes will make sure that you never go over it. All right, so how do you do RBAC in Kubernetes? On the Kubernetes side, the RBAC, role-based access control, can be done on two levels. It can be done on per cluster level, or it can be done on per namespace level. So there is no in between. In Rancher, what we do, we introduce the concept of a project that lets you group multiple namespaces, and you can apply your RBAC rule to a project, and it's going to be pushed to all the underlying namespaces. So in this case, you don't have to worry about creating all the custom RBAC rules for every namespace that you add to your Kubernetes cluster, or when the new user is added to the Kubernetes, you don't have to go and create a role binding for this user. We make it easy, so you can just register a user for a particular project, and that user will automatically inherit all the permissions of the project, and he won't be able to do bad things to other. Now, for the network isolation, Kubernetes has a very good concept of the network policy. So with the network policy, you can configure the way so the namespace A cannot access the namespace C. But with the project concept that we've added, you can configure the network policies on the project level. So in case you want to group your several namespaces together, you don't have to apply the network policy on per namespace level anymore. You can just apply it on per project level. All right, so about the resource quota, we are still piggybacking here on the Kubernetes resource quotas, but we do apply them to the project. So you don't longer need to go to each and every namespace in your organization. You can just say, okay, this project A cannot use more than this amount of CPU and memory, and it's going to apply to every namespace in the project, and you don't have to configure it on such a granular level. And if you have multiple clusters, and you might want to provide a global access for them, you might want to configure the global point of entry for the traffic. In this case, we have the global DNS concept that has a pluggable provider's nature. You can create a global DNS, and you can say, all right, so this global DNS should forward the traffic to the project A and project B. And AWS is our Route 53 as our default provider, but we do integrate with all the providers that are available in the Kubernetes external DNS project. There are plenty of them, like Cloudflare, the Ali DNS that we currently added for our Asian users. All right, so this is my favorite topic, the franchise chain. So what do you have to take, in the case of a global cluster, obviously you have to take care of the RBAC and sharing your clusters with other users. What do you have to take care of when you deploy your Kubernetes cluster to multiple smaller devices? And the first thing that comes to mind is the cluster has to run on a really small device. Like that device can have 1 GB of RAM, and your Kubernetes should be able to run on it just fine. ARM support is highly desirable, and if you're having multiple Kubernetes clusters, you might want to push the same user applications to all these clusters with just one click, and do the upgrade with just one click. Imagine if you have like 100 franchise locations, you don't want to just go and deploy your workload in every location separately with separate API calls. You just want to execute it once and be done with that. And the tough question is like Kubernetes distribution, the official distribution is not small. And I don't know if any of you tried to run the Kubernetes on a Raspberry Pi, for example, or 1 GB device. It does not work well. It requires more resources than a 1 GB device can provide. And this actually was the K3S is the project that came kind of like unexpectedly. The story is we've been working on the service mesh project called Rio, and as a part of the service mesh that we were planning to run on the Kubernetes distribution, we were thinking, it was like, Kubernetes is so bulky, how do we strip the unnecessary components? It has like all the cloud providers code, it has the storage code, and you don't want to have this code on your smaller devices because you don't care about it. It's on-prem, you don't need the cloud providers, you don't really need a storage. So we deleted these components from Kubernetes, and we call this K3S, we call the tool the K3S, and we decided to open source it as a separate project. And it got so much fraction from the community. We got so many external contributions. We did not expect it because it was a side project of our service mesh one. Now, what is K3S? It is production grade and certified. It means that it passes the Kubernetes conformance test. It is CNCF certified. It has one Kubernetes binary with 0 dependencies. You don't even have to have a Docker installed in the host. It uses containerd as a container runtime interface. Another beautiful thing about it, it does not use etcd by default for storage. It uses SQLite. You can still enable etcd if you're used to that, but SQLite is the default one. The most beautiful part of it is just 40 megabytes in size, and it can run on any small device. And of course, it is open source as all the projects that we do at Rancher. And what it does, what it removes all the legacy features from Kubernetes. It removes all alpha features that are not being used. Cloud providers, storage drivers, and Docker becomes optional. And it adds the containerd as the default TLS management. The only one thing that it does not have at the moment is the HA support, but we are working on that. So the other thing that HK's use case calls for is the application deployment. So once you created your small Kubernetes clusters, either on Raspberry Pis or on the smaller devices, you want to start deploying your workloads into these Kubernetes clusters. And you want to do it with one click. You want to roll out your Kubernetes application with one click. You want to be able to override some configs onto a cluster-based level and do the easy upgrades. So we have a concept of the multi-cluster up that you can define and deploy to several Kubernetes clusters with just one command. The multi-cluster up is also a Kubernetes CRD, and you can deploy it just using kubectl. It works perfectly fine. It just pushes application to all the clusters, and it lets you do the upgrade and answers override. I'm going to demo it in 5 minutes. Yep, so it doesn't matter where your Kubernetes cluster is deployed, whether it's on the cloud, whether it's on the edge. We have 0 cloud provider lock-in, and it's just a generic Kubernetes CRD, so it does not have any dependencies. So under the hood, we use Helm support. So we do use Helm to actually push the application to the user clusters, but we present it as a CRD to the users, and you can just query this resource in the kubectl like you would do for any Kubernetes resource. Okay, so we've discussed the things that are specific to the big clusters and specific to the smaller ones, but there are some things that are actually common for any type of cluster that you deploy. And this is basically monitoring the exceptional situations and getting the alerts and getting all the useful logs in case when something goes wrong. And based on my experience, something goes wrong. Every day something can happen. And monitoring, alerting, and logging the exceptional situations really help to debug the situation. And the Prometheus is probably the most popular tool lately when it comes to monitoring. It lets you configure a different set of metrics, and we run it as an embedded monitoring on the cluster level, on the node level, on the project level, on per pod level. So you can see what's going on the top level, on the cluster, or if some application consumes a lot of resources, you can view it on per application basis as well. All right, demo time. I'm the master of failed demos, so please bear with me. All right. Here we go. So this is a Rancher UI. Rancher itself, I started it in a Docker container. The only one requirement that you need is having Docker on the host. I can start it on my Mac OS. And in the Mac, you just need to have some sort of reverse proxy. I use ngrok. But this particular Rancher instance ran on EC2. EC2 has been behaving good for me in the demo situation. I like DigitalOcean in general, but sometimes it can get too flaky. So here's the global view. Here's where I see all my clusters. So I have this one big enterprise cluster. I have one K3S cluster. And if you want to add one more, we go. All right, so we don't bound you to any specific cloud provider, and we don't bound you to any specific kind of installation. So if you want to use the Kubernetes public offering, like GKE or EKS, you can do it. You can choose either of those. And what we do in this case, we just talk to the cloud provider APIs to create a Kubernetes cluster. The other way of deploying the cluster is to provision the nodes on EC2. So we help you to provision the nodes on EC2, but we use our own generic installer, which is also open source, to roll out the Kubernetes cluster on these cloud providers. And we have just 4 node drivers here by default, but we have support for pluggable drivers like OpenStack or any custom driver that you want to write and drop. It can work. And this option, custom, is for can be used either for bare metal nodes or it can be used in the auto-scaling use case. So in case of the custom cluster, we're just going to give you the command that you can bake into your Cloud init script, and this command will automatically register your cluster into Rancher. And if you just want to try Rancher, but you already have your Kubernetes clusters, you can import the clusters into Rancher, and you will see them along with other clusters in the global view. We are not doing anything evil, and the clusters can be ejected at any point of time. And here you choose, here you go, just choose node option. You can choose Kubernetes version you want to install. And here's where you choose the network isolation. So there are all the CNI drivers that can be used in your Kubernetes cluster. And by default, the project network isolation is disabled, but you can easily enable it. And what it will do, it will limit the traffic between the projects after the cluster is created. And there are more advanced options. If you're an advanced user and you want to put more custom options into your Kubernetes cluster, you can do it here. Right. And we also, Rancher, how Rancher does authentication, it sees this authentication proxy in front of all the Kubernetes clusters, so you don't have to configure your authentication in every cluster. You can do it just once. And we have an integration with all these authentication providers. Okta is something that was recently added. There's a GitHub that is popular, Active Directory, basically. And what we do is we authenticate the user request that comes to the Rancher API, and then we forward this request to the user cluster. All right. So once your clusters are configured, you might want to enable monitoring on them right away, just to see what's going on with this guy. So just check on this cluster view. Here's with the Prometheus enabled. Come on. OK, you can see the CPU utilization. You can see memory utilization. You can also do it on per Kubernetes cluster components like etcd or Kubernetes API server. And this is on the cluster view. If you want to see the Prometheus metrics on the node level, you can do it as well as on per individual workload level. And here's the projects view. So once the cluster is created, you can start structuring your organization. You can start creating the projects. Here we go. So once the project is created, you add a namespaces to it, and once the namespace is added, your users can start creating the workloads. And if you want to configure global DNS, you can first configure your provider, and then after the provider is configured and knows how to talk to the AWS S3, you can start configuring the DNS records for your applications. But now, let's try to register the really small edge cluster into Rancher with K3s. Here we go. All right. This is it. This is K3s, a repository on the GitHub. It explains what it is. It is 5 times less than Kubernetes. And I really like this prerequisite. It's very useful in situations when PhDs in Kubernetes clusterology is not required. So, okay, I wanna install this K3s on EC2 node that I've just provisioned. I have not installed anything on that EC2 node. I've just provisioned this Ubuntu 16. The node does not have Docker, as K3s just uses containerd that it comes with it. I don't have to install any dependencies on this host. So, can you all see the screen? I'm just going to move it a little bit to the top. Just close this coding stuff. All right. So I've downloaded the binary. I'm just going to follow the steps. So the steps are pretty simple. I'm just going to download the binary, and then I'm just going to execute this command. Come on. What's going on? All right. It is doing something. Okay, so it's creating a bunch of CRDs. Okay, so at the end, after the cluster is provisioned, and what it does, it actually starts the Kubernetes API server and Kubernetes node on the same virtual machine. So it's going to be like the case where your Kubernetes cluster doesn't actually have to be spread across nodes. It's going to exist on just one node. So once that is started, let me log into it and just try to see if that works. So there's my EC2. Okay. All right. This is my K3s host. No, like this. Okay, so the GitHub instructions just tell me I have to run this command, and after that, I should be able to execute a kubectl and see the internals of my K3s cluster. Let's test it out. Get node. Let's see the basic command, get node. All right, I see myself, and I see the Kubernetes version, it uses the latest 13.4, and it is ready. So it means that I can start deploying the workloads in this cluster. But at this point, this cluster is independent, and I would like to import it into Rancher, so I can use the Rancher UI for deploying the workload. So for that, I have to go to my cluster view, and I want to choose the import option. Add cluster. I want to choose import. I want to name my cluster K3s backup. Here you go. All right, and it gives me the command that I have to run on my Kubernetes cluster in order for its cluster to be registered. I'm just going to copy paste this command. I'm going to back to my command line. I'm just going to feed this command to my K3s. Oops, something is unexistent, so I think I copied the wrong command. If you get, I think I need to do this. Command V. The only one thing that I have to replace is this kubectl apply should be the one that is coming with the K3s binary. All right, so it created a bunch of things. It created the service account, it created the role bindings, and the deployment that will start the Rancher agent and register this cluster to Rancher, supposedly, I hope. All right, so it is, oh, here you go. You can see that this cluster just got imported. It has our K3s Kubernetes version, and looks like it's pulling some stats, and it's just waiting for the API to be available so we can start. Oh, cool. It is up. Yeah, did not fail. but, okay, it says it's active, but I don't trust you. I just want to see if I can access my cluster from here, from the UI, just to see if I can launch the kubectl. So Here we ship the embedded kubectl that lets you access any cluster from the UI. OK, so it is working. It is actually pulling the data from the Kubernetes. Yes. So you can also Thank you. If some people they don't like UI and they prefer to run the kubectl from their command line, you can just copy this kubeconfig file and connect to any Kubernetes cluster that we provision with Rancher. And OK, so I don't have any monitoring enabled for this. And just a little disclaimer: Prometheus is a very heavy on CPU and memory consumption. I don't want to try to enable it on my really small host with just 1 GB of memory because it might not work. So I'll just leave it as unmonitored. By default, even without the Prometheus, there's some sort of monitoring, some health reporting for the Kubernetes cluster components, just not very extensive as the Prometheus one. And I want to try to deploy some application on my K3s cluster. So I'm choosing the default project. Yeah, it's pretty slow. OK, and here I just want to deploy the workload. I'm choosing the very basic option. I just want to deploy my Ubuntu K3s Ubuntu. And I have just one host, but in case you want to run as a daemon set, you can choose this option, run 1 pod on each node. But in my case, just 1 pod is fine. All right. Cool. It is deploying something. It is probably deploying the pod, pulling the images, and it's green, so it's working. Right. And if you want to see the logs on a container level, it could be done here. I don't think Ubuntu is going to give me anything useful in the logs, but there is a way to pull the logs from your running container in here and all the other useful information. And we don't do any custom calls in order to launch the Kubernetes workload. Whatever you do in the UI gets translated to the native Kubernetes object and native Kubernetes call. And you just can see the YAML representation of the Kubernetes resource that Rancher creates. All right. And let me go back to my slides. Here are some links to the project that I've demoed today. One is Rancher, one is K3s, and the multi-cluster app that helps you to roll out your application across multiple clusters. And here's a little information about me. Here still is my old title that I miss a little, the engineer. And you can find me on Twitter. You can find me on GitHub. All the projects that I work on are open source and on the GitHub. If you have any questions, please reach out. And thank you so much for listening to the presentation.